Okay, intermediate value theorem. Let f be continuous on a closed interval AB, and let n be a number that's somewhere between f of A and f of B. You don't have to memorize this for the test. Yep. Then there exists a number C in AB such that f of C is equal to n. So this is it means in. So there's a lot of shorthand in mathematics that I need to start showing you guys. So when you take classes in college, you don't get lost. But for example, that would be epsilon. That would be E. It's in. It's like a C with a line, extending from it. So we say that that's in. Uh, this is a symbol for such that. This is a symbol for all. For all. Whatever. See? See the number. Okay, you just wrote a bunch of stuff down, but you don't know what it means, right? So let's figure out what it means. Let f be continuous on a closed interval AB. I'm going to draw a function over a interval AB. I drew a function over an interval AB. Okay with that? What is this spot right there? No. Good guess. Try again. No. 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 F of A. Thank you. What's that point? What's that number? F of B. There is a number n. And how does n compare to f of A and f of B? It's between it. So I'll put n right here. Okay, so that's the setup. It says let f be continuous on closed interval AB and let n be a number between f of A and f of B. It says then there's a number C that's between AB such that f of C is equal to n. So here's the idea. If I follow this height over for n, sooner or later I'm going to come across and hit the graph. And when I follow that down to the x value, we'll call that x value C, says that C has to be between A and B, such that when you take f of C, you'll get that number n. Now, sometimes the intermediate value theorem is best explained by looking at general examples. Assuming that this isn't Mission Impossible or something like that, if I wanted to get from this position right here over to Miss Nelson's desk to talk to her, true or false, I would have to pass through that door. Yeah, I mean, what else would I do? Okay. Breach the wall, exactly. Crawl through the ceiling. You guys are all identifying Mission Impossible ideas. Okay. I would have to walk through that door, right? There's no way I could get around it. Now, before I get to that door, I might take 5 steps. I might take 48 steps. But I eventually have to walk through that door. That's just the way that it goes. If I want to get from here to Miss Nelson's room, could I pass through the egg department? Could I pass through the office? Could I pass through the cafeteria? Yes. Do I have to pass through the cafeteria? No. But do I have to pass through that door? I sure do. Now, let's think about try to generate a counterexample. Maybe this will make even more sense. I need a volunteer. Who's going to be my volunteer? Okay, Colton's my volunteer. I've got A and I've got B. And I've got what? No. Okay. And I've got f of B and I've got f of A. Okay. So this is going to be my starting point right here. And this is going to be my ending point right here. Colton, I need you to help me pick a spot for where n is going to be. N has to be somewhere between here. Okay. You tell me where n should be. Okay. You want n to be right here. Great. All right. So what I'm going to try to do is I'm going to try to draw a continuous function from f of A to f of B. But I don't want to ever achieve a height of n. Think I can do it? What do you think, Annika? Do you think I can do it? You do. I like the way you think. Oh, it's a bad start. And shut up. Okay, so I'm close. Right? There we go. Right? Annika. I got it. Okay, so what's wrong with that? There's two things wrong with it. It's not a function, and it achieves a height of n that's outside of the interval AB. Yes. I don't know what you're talking about. I'm sorry. Oh, so like if we have, oh, right. Yes, exactly. But that number, it says that it's a continuous function. So excellent point here. So that actually comes up. So Eli's question is simply this, okay? It starts off by saying that it has to be a continuous function. So I had a professor in college who, he drew it another way. He's like, well, come on, let's try. Let's not give up the first try. Let's do this again. So he came back to the spot and he said, here's what we're going to do. Well, you won't do that. Oh, okay. Thought you would go back and erase, but you won't. So he said, let's try this again. Let's do the same thing, only let's play just a little trick on this. I like this. See, Annika, what I like is you had faith. You think inside that I can do anything, okay? Which I understand. But it's not true. It's not true. So let's try this. Get to Eli's point. I get close. I don't want to cross over n. So what I'll do is I'll just zip right between here with a little dot, okay? So what's wrong with that? It's not continuous. I had to pick up my pencil to draw it. So you get the intermediate value theorem, why it works. It's very important because on the AP test, you have to invoke the intermediate value theorem. I want you to be able to do that. And by invoking it, you can just write IVT, and people know what you're talking about. We use it to discuss continuity and then also these intermediate values. Let's try example 1 and get to the algebra. Explain why the function has a 0 over the given interval. What does it mean to have a 0? Crosses the x-axis. So the y value is equal to 0 somewhere. Well, I can, do this pretty quickly. Number one, I know that f of x is continuous. Anybody, yeah, how do I know that this function is continuous? I'm a wizard. There's no extraneous solutions, okay? But also, this is a polynomial, right? And all polynomials are continuous. In fact, we can even prove that. Is sine continuous? Yes. Is tangent continuous? No, it's got vertical asymptotes, doesn't it? How about cotangent? Nope. How about cosecant? Well, last year we took a class called college algebra and college trig. So sine looks like this, right? Whereas tangent looks like this. Remember those? I got to pick up my pencil and draw them, so therefore it's not continuous. Okay, so sine's continuous. So is this. Is letter B down here continuous? What value is it not continuous for? -2. So that's a problem value. We'll talk about what we do when we get to that. So f of x is continuous. Here we go. First, I would identify what f of -2 is. Anybody, what is f of -2? -8. What is f of 1? 4. So because f of -2 is less than 0, which is less than f of 1, there must be a 0 in the interval -2, 1. Yep. Actually, the whole thing's my answer. Said explain why. So first of all, I have to state it is continuous. Second of all, I want to state that it has 2 outputs. Now, why can I say this so confidently? Somebody make sense out of this to me. Like, think about my drawing. Yeah, I came out with a negative value, and I came out with a positive value. So if I want to draw from a negative spot on the graph to a positive spot on the graph, at some point I have to cross over what? Yeah, so I'm at -8, and then I want to go to 4. Okay, so I want to go from there to there. At some point, I have to cross over the x. Whoop. Okay. No, see, it doesn't work like that. You got to cross over the x-axis, right? Have to. So that's how we verified that. So you want to find that you get a positive and a negative and do that. Go ahead and do B on your own. You might have to use your calculator unless you know what the sine of 5 pi over 4 is. Yep. It means in. Did you come up with 1 and -1.12? Okay. So again, if we want to get from -1.12 to 1, or in this case, we're trying to get from 1 to -1.12. And so we have to cross over 0 at some point. So some people didn't like, during second hour, they wrote 5 pi over 4 first. You understand why I wrote 5 pi over 4 first? Yeah, because that's less than 0. Yep, if you want to write it like that, that's fine. You have to state that it's between. So if you want to switch around the inequality sign so it's greater than, that's fine. You just have to state that it's between. Got it? Okay, let's look at the next one. It says verify that the intermediate value theorem guarantees there is a 0 in the interval -1, 2, and find the 0 by using a graphing calculator. So first of all, is this a polynomial? Yes. And since it's a polynomial, I just made these notes this morning because I didn't like the lesson from last year. We do have to switch that to minus. That's the one mistake on this. So it says verify that the intermediate value theorem guarantees there is a solution in the interval -1, 2, and then find that 0. So first of all, we know it's continuous because it's a polynomial. If we want to find guarantee that there's a 0, we have to show that f of -1 and f of 2 have outputs that will change sign. So one has to have an output that's positive, and one has to have an output that's negative. If I plug in -1, what do I get? -1, right? Yeah, I'm sorry, change it from positive to negative, because otherwise it doesn't work out. And now I'm going to plug in 2. 2 to the fourth is 16, minus 4 is 12, minus 1 is 11. So does there have to be a 0 between -1 and 2? There does, because one's negative, one's positive. So I have to cross over 0 at some point. So let's find that. So we'll take 0 and set it equal to x to the fourth minus x squared minus 1. Now, we could use quadratic form and then the quadratic formula to solve that, but it says use your graphing calculator. On the AP exam, you'll be asked to use your graphing calculator as well for a problem like this, because solving this quartic, although there's more difficult ones, is not that easy. And so we're going to go x to the fourth minus x squared, and then minus 1. And on the AP exam, they want you to list your answers to the nearest 1,000. So we should get ready for that. On your test, I always ask for the 100th. We'll modify that and then go to the 1,000. So I look at graph. Does this graph cross the x-axis? Am I looking for the first spot or the second spot? Why the second? Because that's between -1 and 2. And in fact, if you zoom as a box, if you want to, you don't have to, but I'm going to bring the x value over so that's closer to, say, -1. Enter, and then I'm going to bring the x value over so that it's closer to +2. I'm looking at the one to the right because it says that you're on the interval of -1, 2. So the other one is outside of that interval. No, it's an interval. So between an x value of -1 and an x value of 2. So you can look right here. We'll pick up when we get back, but it's approximately 1.27. We'll use our calculator when we get back to find that exact value. See if my calculator will turn on. Probably not. Okay, so we go second calculate, and we find the 0, number 2. And so this is what you will be expected to do on the AP exam, is sometimes you have to use this feature, is to find your 0. And it sounds like a few people already got it. I go to the left, I go to the right, and I press enter, and there we've got 1.272. So is 1.272 in that interval? Yeah, it is. Okay. So I was on the calculator and I typed in my function, and then I went to second calculate and I did number 2 for a 0. And I went to the left and the right. And that should give it to you. Okay. Why don't you try letter B on your own? Go. Yep. X is 1.272. Right? Yep. Um, you could solve it algebraically in this example. I didn't. I'm going to solve it using a graph, but So the TI-83s are not as smart as the other calculators. So the TI-83s will show this vertical asymptote piece. So that's why your graph maybe looks like mine. But otherwise, I'm guessing that the rest of your graph looks identical to this. Yeah. So we're going to calculate number 2, the 0. And you can see you get negative 2/3. Now, I have a question for you guys. Is this function continuous? No, the function is not continuous. So if the function isn't continuous, why were we able to use the intermediate value theorem in this problem? Because it's continuous over the interval. You see that this function is discontinuous at negative 2. Is negative 2 in that interval? If it was, then you would say it doesn't work. Okay? Can't use the intermediate value theorem. Can't guarantee anything. Okay? So we got negative 2/3. Flip it over. Verify the intermediate value theorem applies to the indicated value of C, then find C guaranteed by the theorem. So here it says f of x equal to x squared plus 4x plus 1 over the interval negative 1, 3. And instead of looking for a 0, we're wondering if the function achieves a value of 6. First of all, is the function continuous? Yes. So let's see if the intermediate value theorem will apply here. I'm going to find out what f of negative 1 is. Plug in negative 1, what do you get? Negative 2. And plug in 3. 22. So is 6 between negative 2 and 22? So the function must achieve a value of 6 at some spot. I want to find the C value where that happens. So I will say x squared plus 4x plus 1. Where is that equal to 6? At what point does it equal 6? I'll subtract the 6 over. We're solving a quadratic. I'm going to factor to x plus 5 and to x minus 1. I get negative 5 and positive 1. So what's my answer? What is my C value? C is 1. Why? Why is it 1 and not negative 5? Because your interval is between negative 1 and 3. Is negative 5 within that interval? No. Is 1 within that interval? Yeah, so therefore we choose the number 1. Okay, look at B. Does the intermediate value theorem apply here? Is the function continuous? Where is it discontinuous at? Is 3 in that interval? So therefore, the intermediate value theorem does not have to apply to this situation. If you have a discontinuity within that interval, we would say intermediate value theorem does not apply. Second of all, if you were actually to type in some numbers here, let's say you didn't recognize that, you did f of 0, you plugged in 0, you would get 0 minus 3 is negative 3, squared is 9. 2 ninths plus 1 is 11 ninths. And then if you did f of 4, you would get 3. So look at the value that you're looking for. You're looking for where f of c is equal to 1. Is it guaranteed to equal 1 within that interval anyway? No. But from the very beginning, you would say that because x cannot equal 3, and 3 is in that interval, the IVT does not apply. Yes. The IVT would apply. Yes. But even as you set it up, you would say, it says verify that the IV applies the indicated value of C. Well, first of all, you would say the intermediate value theorem is in play here. We could use it. But at this point, we get 11 ninths and 3. Is 1 between 11 ninths and 3? So you would say, doesn't necessarily have to be true. Yes. Okay, 2 more examples. It says show that the following function, shouldn't be functions, function is continuous at x equals 1. This is a piecewise function. We need to know how to sketch these and graph these. These are on the AP test. So I'm going to make a graph. What does the first graph look like? Yep, shifted upside down, up to 4. And if you plug in 1, what is the output? 3. Look at the second one. My input is 1. What's the output? 3. What does that graph look like? It is a horizontal line, but it's just for one x value, so it won't be a line. It'll just be a point. Okay? And then the third one here, if I plug in 1, 1/2 times 1 is a half, plus 5 halves is 6 halves, or 3. It's a good thing we get 1, 3 for all of those, isn't it? So the first graph has an open or closed circle at 1, 3. Open, and that's what it looks like. What happens with this point? Fills it in. And then your third one starts there at an open circle, and it heads off at a slope of 1/2. So it says show that is continuous. What are the 3 conditions that have to be satisfied for continuity? What's the first one? F of A must exist. So F of 1 is equal to 3. What's the second condition for continuity? The limit. The limit as x approaches 1 of the function is equal to, let's approach it from the left, and let's approach it from the right. What is it? 3. And then the third condition says that they have to be the same. So the limit as x goes to 1 of the function has to be the same as when you plug in 1 for the function. And since those are both 3, that statement is true. So we have verified continuity. You okay with that? And the last one. This is the most fun one. I know they're all funny. Like, where would I even start if I want to pick the most fun one, right? Okay, so prove that there is a number that is exactly 1 more than its cube. Oh, think about it, folks. Give me a number, Annika. 2, great. Is 2 equal to 1 more than its cube? Nope. Try another number. Who wants to try one? 4. 4. Is 4 1 more than its cube? No. Try another one. Half. Okay, we'll do that. 1/2 is that 1 more than its cube. So a half, and here you would get 1 1/8 or 9/8. So a half is a 9/8. But we're closer. 1/4. Is 1/4 equal to 1 plus a 4th cubed? That would be 65 fourths, or no. So I'm sorry, 65 64ths is not the same as 1/4. So it doesn't work out. Do you think there's a number? There is. It happens to be negative. But I'll show you how we can verify that for sure it is true. So let's make a statement. Is there a number that is 1 more than its cube? Oh, look at that. I have a function. Is the function continuous? Yeah, baby. 0 equals x cubed minus x plus 1. Oh, now I'm stating that that function has to have a 0. Does it have to have a 0? First of all, it's cubic, so it has to have a 0. Second of all, we're going to invoke the intermediate value theorem. A, it's continuous. F of x is continuous because it is a polynomial. So I just want to find that it has an output below 0 and an output above 0, right? Can you think of an input that would give me an output below 0? Just pick one. What do you want? Say -2? All right, way to go, Sam. F of -2 is, so it'd be -8 plus 2 is -6 plus 1 is -5. Awesome, we got a -1. Can you come up with a +1? 1. Plug in 1, you get 1. So it's got to, I mean, we have a 0 somewhere between -2 and 1, don't we? So by the IBT, we invoked the intermediate value theorem. There is a 0 in the interval -2, 1. I'm going to find it. X to the third minus x plus 1. And I graph. What up? Because I know that the 0 is not going to be at -2, and I know it's not going to be at 1 because neither of these are 0. If you use brackets, it would also be acceptable. So I'm going to calculate the 0, and I press enter and enter. I don't want to guess. -1.325. And if you take that number, 1 plus, parentheses, -1.325, and you cube it, see? Get that number. Cool, we found it. So there's your proof. All right, your assignment is a worksheet.